Welcome to another video. This is for Part 5 Networking. What you're going to find when you open up the PowerPoint is that we don't have any commands for networking until slide 13. So I'm not going to talk about the part of the PowerPoint from slides 1 to 12. You'll need to read that, and then if you have any questions about it, please email me, so if I need to clarify anything, I will. I will make reference to some of the information talked about in slides 1 through 12 when I do use the commands I'm going to be demonstrating in this video. So, in order to do some commands, we need a command line. So I'm going to open up the command prompt or command line in admin mode because there's at least one command I'm going to be demonstrating that you have to be in command mode to use. So I might as well just open the whole thing up in command mode. Now, one of the things you can do to check some networking information is you can determine what your IP address is. And as I talk about in the PowerPoint, every computer that connects to a network nowadays has to have a unique IP address. Prior to, say, 20 years ago or so, there were some competing standards, but the current standard is TCP/IP, and that means you need to use an IP address. So, one of the commands you can use to check your IP address on your computer is to type ipconfig. Now, if you've used Linux, you may recognize this. In Linux, you use an F instead of a P, so the command is ifconfig. But on Windows, it's ipconfig. It gives you the same information. Now, you can type ipconfig without any switches at all, and it gives you a default set of information. So what it'll give you is what your IPv6 address is and what your IPv4 address is. And if you've looked at the PowerPoint at all, you may recognize this IP address as being a private IP address. Since we're on my home computer, I've got a wireless network set up at home, and I have my computers assigned private addresses that will only show up on my local network behind my wireless firewall. So the IPv4 address is 192.168.1.106, and here's my subnet mask. And subnet masks are important because it determines what network your computer is on. And so the TCP protocols and IP protocols will use this subnet mask to determine if you're on the correct network or if you've assigned a correct IP address. Now the gateway here, that determines where you can connect outside of your network. And your gateway address is usually your wireless, well in my case it would be a wireless router, but on a network, say at Delta or in a business, the gateway is the router which can take you to other networks in your company or business or at college. The rest of this you don't have to worry about. Default gateway, it's giving you specific IPv6 information. As I talk about in the slides, IPv6 is the current scheme that's used to assign unique IP addresses to computers. Excuse me. And then, as you can see with this connection information, that my internet connection provider is Charter Cable Company. Now, there are a couple of couple of switches that you can specify. I'm going to use one of them and I'm talk about the other two. ipconfig/all will actually give more information. So as I scroll up here, some of this information is this. You can see is the same as what we get. What was shown before, but it also gives more information about computer names, connection information, and then there's also this information here. Teredo tunneling pseudo interface has to do with sending IP version 6 IP information over an IP version 4 connection. I don't think I talk about this specifically in the slides, but there is a lot of equipment out there on the internet and in local networks at your companies, businesses, that still only support IP version 4 addressing. And the reason for that is it's expensive to upgrade to IPv6. If you have devices that support IPv4 and devices that support IPv6, you need to run equipment for both of those IP addressing schemes. They're not compatible, I guess is the correct word. So if you run IPv6 equipment only, that means your devices cannot use IPv4 addressing, or they at least have to have both IPv4 addressing and IPv6 addressing. So it's just a matter of it's going to take a while for all of the equipment to get switched over to using the IP version 6 addressing scheme and only the IP version 6 addressing scheme. So you're going to see both the addressing schemes, version 4 and version 6, for a while. All right, I'm going to do help ipconfig. Oops. All right, ipconfig /?. Thank you. All right. There is more information. There is more switches, obviously, here. The two that I want to talk about are these release and renew switches. When you're on a network that uses something called DHCP, which I talk about in the slides, sometimes when you're having trouble connecting to a network, you can use this release switch to tell the computer to forget the IP address assigned to it. And then you use the renew switch to tell it to go contact the DHCP server and request a new address. So those are a couple of troubleshooting techniques to try to see if maybe, for whatever reason, your computer and another computer on the network happen to have the same IP address. Remember, IP addresses have to be unique. Or maybe the computer got moved. If you're in a company, that happens all the time. And so when you connect the computer up in a different area, you could have to have a new unique IP address. And instead of typing it in manually, you're going to use the DHCP server. So this is how you would get that computer to contact the DHCP server and request a brand new address. Now notice you have separate release commands for both version 4 and version 6, and you have separate commands for renew commands for version 4 and version 6. And again, you're going to see this for a while until everybody gets their equipment upgraded. Again, it's very expensive to upgrade the equipment all at once. So it makes sense for companies to do this slowly over a period of time. Now, the next command that I'm going to demonstrate is called the netstat command. And if you've got the PowerPoint slides. I'm on slide 13. So if you do netstat all by itself without any switches, this will just show you what your current connections are on your computer. And right now it's saying my current connections are using a local address of 127.0.0.1, and it's connected to, and it has a number over here with a colon after it. So the first part of netstat shows you the IP version 4 IP address that you're connected to locally, and then this number after the colon is what port, that's spelled P-O-R-T, that you're connected to on that particular IP address. And again, if you look at the PowerPoint, you see that this is a local address that's used for testing. So because I'm running a virtual machine on my main computer, the addressing, the foreign address here is actually my own computer, establishing a connection with my virtual machine so I can share files. And the state here, you see it is established. Now 192.168.1.106 again is the IP address for this virtual machine. And these numbers followed by, these numbers that follow the colon are the ports that are established when you can connect to a computer. So you can have a lot of different services on networks or the internet connected to your computer at the same time, and they're all uniquely connected to your computer by something called a port. And right here established, I have a web address established, MSN bot 6552.108. I'd actually have to do a little bit more digging to try to figure out what that is. And there's some other HTTP addresses that are waiting for connections right now. It's possible I left something going on my main machine, or it's also possible that these are update services, for instance Windows Update, that's running in the background, and it's already got a connection established, and it just leaves the connection and the service will go out and actually connect to Microsoft's site, and later on you might see something sitting here say established. Again, when you see connections here and you don't recognize them, you're probably going to want to go and see if you can figure out if this particular port number is used for anything specific. You can Google port numbers like 49406 and see if there's a specific service that usually uses that port. Alright, now to get more information about netstat, you can type netstat /?, and there's a lot of options. Now I say options instead of switches because notice when you use an option with netstat, you have to precede it with a dash, like this -A here, that displays all the connections and listening ports, whether they actually have a connection or not. So they use a dash instead of a slash, so I tend to refer to them as options rather than switches. So I'm just going to talk about a few of the options here. Again, -A will display all the connections that you might be able to establish, and if I specify that, and I'll type that in here, netstat -A, you're going to get a lot of stuff back. And sometimes it doesn't display all at once. It takes a while for everything to display. And sometimes there's more than this, but you notice I have several items here listening and several items that are established. And now what I'll get is you'll get some of the IP addresses in IP version 4, and then down here the addresses that are in square brackets are actually IP version 6 addresses. The reason you have zeros is because there's this port is listening right now. Your computer is listening on that port for particular connections. Again, I would have to do a little bit of digging to discover, okay, what port has been assigned to that particular service. And there is a couple of issues here because if you actually go into networking, you'll find that there are some ports that are called well-established ports. They're always used for the same things. But ports that are up in the 49,000 range here usually aren't well established. They can be used by anything. So having ports assigned to your local address from this group is not a problem. I would be more concerned about the port that's being used over on from the foreign address and see what's going on. But there's nothing connected. That's why there's all zeros here and here under foreign address. It just means that there happens to be listening by your computer on those particular ports. And the same goes for the IP version 6 addressing. This is how you specify all zeros using IP version 6. And then down here there's actually a this is my IP version 6 IP address, and it's listening for anything coming in on port 1900. And again, I'd have to do a little bit of digging to see, okay, what the heck, why is it listening on port 1900? It's usually not a problem, but yeah, it's just kind of nice to know what's going on with your system. Now, you can have it display IP addresses instead of names. So if I specify netstat-n, now everything under foreign address shows up as an IP address. So you can see 127001 is coming back to 127001, and that my computer's IP address is listening on port 49406, is connected to IP address 65.52108.205 on port 443. And I would have to do a little bit digging, but I think that's Windows Update Services right there. Again, I'd have to double check it, but I'm pretty sure that's what that is. All right. I do list some other options in the PowerPoint slide. You can display connections for specific protocols. I don't have enough connections right here, I think, to actually demonstrate, but the -P option I list on page 14. You can specify -P followed specifically by a particular type of connection. Again, if you go into networking, you'll get more information about what a TCP, a UDP, ICMP port is. But I'll try it here and see what I get back. -P followed by, I'll say, UDP. See if I get anything back. And there isn't anything connected or listening on UDP at the moment, so there's nothing listed. All right. Now, since we have a connection, we can set netstat-o, and this should tell me the process number of whatever process is connected. And this connection for MSN bot has a process ID of 1336. So you can now go into your process tasks, and I'll just right click on the task manager and bring that up. And I can look for the process ID of, and here's my processes tab. So let me make this a little bit bigger. I can look for process IDs of 1336. Right. And okay. That's interesting. All right, the problem here is with me, not with the process. So I haven't actually opened up the task manager under Windows 8. And so I'm used to the Windows 7 task manager, which gives me the process ID number, not the name. So what I'm trying to do is find the services. There we go. That's what I'm looking for. Okay, so if I look for 1336, I can sort by the PID number. Oh, that's interesting. There's no process ID number of 1336. Okay, that's not okay. So what's 2448? That may not show either, and it doesn't. 4148? Ah, okay. So let's do another netstat-o and see what I get back, and it shows there's one established. That's weird. It doesn't. The only reason that I can think of that it wouldn't show in the services is that it's not actually doing anything right now. But let's see, I do have services here that are stopped, but they're not assigned a PID number. Okay, well that's interesting. Details, PID, sort by PID. See what we got. Oh, there's 1336. Okay. Explorer.exe is running a process and of process ID 1330. Why didn't it show up in services? Okay. All right. So Windows Explorer is, why is it connected using an HTTP connection? All right, well that would take me, I have to do a little bit of digging of why Windows Explorer, this is not Internet Explorer, this is this guy, has a connection established, a TCP connection established. That's a little weird. I know you can do some networking searches using the Windows Explorer, but I wasn't doing anything. Matter of fact, right now it's closed. Okay, so if you use these commands, be prepared to have some interesting results that you might not want to get, because right now I don't have time to go digging into that and see what the heck's going on there. I don't think anything nefarious is going on. It shouldn't be, but it's a little weird to see that. All right. So, but for right now, just going to leave that, and I'm going to go ahead and close up the task manager so I don't keep staring at it wondering what the heck is going on. All right. One of the other things I want to show is that you can combine these options. So, for instance, if I want to display the numeric IP addresses instead of names and the process IDs, I can combine those options, and I can say netstat -n and then O. And what it'll do is it should give me everything using IP addresses and what the process IDs are. So I can see exactly what IP address is being connected to on a foreign address, and then do a little bit more digging. 443 is a secure connection, at least. I recognize that foreign port. Um, uh, so that's a well-established address. That's a secure HTTP connection, usually using SSL. Then you have your standard port 80 for regular web connections to 172.224, 247.117. So again, I'm not expecting those, so I'd have to do a little bit more digging. So it'll be interesting to see what that ends up being. But that's all I really want to show you for netstat. All right, on slide 15, I talk about commands you can use that allow you to connect to another computer and transfer files. So for instance, we can type FTP is the default program you use to establish a connection and allow you to transfer files. So, however, it's not secure. So if anybody was listening on my network or between me and the computer that I'm connected to, they would see my login name, my password, and all the other commands I issue, basically in clear text. But I'm going to go ahead and do this anyway. Everybody has a connection, I'm sorry, everybody has an account at Delta on a server that allows you to play with web pages. So I'm going to type student.delta.edu. And this is typical of whether you use FTP or the secure protocol called SFTP. Wants your username, it's me, and wants your password, which in this case is just my Delta password. Now notice one thing, you can hear me typing, but right here in password, unlike when you log in at Delta, it does not display anything back to you to let you know that you've typed in something. So it's a little disconcerting until you get used to it. So hopefully I typed in the password correctly. So whether I had dots appearing as I typed it in or not, I could still do typos. And I'm logged in. And when you connect in, this is what you get. You get this FTP prompt. And now you can just simply type some commands. There is a few commands that I list on page 16. And one of the commands actually I don't list is dir, which we've been using for listing our directories, but you can also use that in an FTP session. So since I also teach an HTTP class or web design class using HTTP coding, here, I've got a few files up on this server anyway to demonstrate what's going on. So I'm going to go ahead and I'm going to demonstrate some of the commands. So for instance, hash usually prints a hash sign every 1024 bytes. That's the default, but I believe on the Delta computer they've changed it so it displays a hash for every 2048 bytes that is transferred. So if I type hash, it just tells you that it's on. And so now, let's see, I was in System 32. The problem is there's no way for you to change your directory on your local computer. That's one downside for using either FTP or SFTP. So I can put a file from the local computer, meaning my computer, on student.delta.edu, but now I have to specify the whole full path name. And you'll have to excuse me. I'm going to open up another window here so I can, this I'm just going to do a simple window so I can figure out what files I've got where. Alright, so I'm looking for something that's fairly big. So you can see the hash mark. So I have something help update messages.txt. So what I'll do is I will get that. Alright, so Mark Monica / help _update _messages.txt. Connection closed by remote host. Okay. One downside to taking too long to doing things is they may have it set on the remote computer to close the connection if nothing happens within a certain amount of time. And that's what they've got set here at Delta. So what you have to do then is to end the connection, make sure everything's closed, say bye, and then just simply start over again. But since I have to close it anyway, I'll just do this. Alright, there I am. Okay, so there's my big file. And so let's go to FTP student.delta.edu. I'm going to move my pointer out of the way. Logged in. Okay, there I am. Alright, so hash. Okay, so let's put help _update _messages.txt. Alright, so that's what it looks like when you successfully transfer a file from your computer to the remote computer. And here it has hash or pound signs. That's what it means by the hash. So hash sign is that sometimes called a pound sign. So, and if you see hash mark printing on, you'll see it says 2048 bytes for each hash mark has been transferred. So without that, this transfer would go really quick, but if it's a really big file, say a picture or something that's over a megabyte, without turning hash on, it would just sit there and you wouldn't know for sure if anything was happening. Excuse me. Now, the reverse of that, as I have listed in the PowerPoint, is to get a file from the remote computer and then transfer it to your local computer. And I have a file out there that's not too big, just go error.png. So what I'm going to do is just simply get go _error.png. And there we go, and it transferred. All right. Now .png happens to be a graphics format, and it wasn't very big. I don't even remember what it was exactly, but I just wanted to show you what it looked like. Okay, that's FTP, and as I talk about in the PowerPoint, the FTP is not secure, so technically I'm running a risk using FTP. I'm kind of guessing nobody's sitting outside my home at the moment trying to hack into my computer system. But SFTP is definitely better, but you have to use a separate program in order to get secure file transfers. So let me just do by. All right. Now, the other item I talk about on page 16, Telnet and SSH, is Telnet allows you to connect to another computer and then control that computer, but just like FTP, it's not secure. I'm sorry. So what you want to use is SSH to connect. Now, if you have used Linux, Linux, I think I've mentioned it before, then you have heard of SFTP and you've heard of SSH, so you're familiar with using those. I do have a program here called PuTTY. So that's the type of program you would have to install on Windows in order to get an SSH connection, but it's not command line. It's a program you would use through Windows. So technically at the command line, Windows does not give you something to make secure connections without having something already installed that would allow you to do that. All right. So what I'll do is I'll simply click cancel. And I don't believe the X server at Delta allows Telnet connections, but I'll give it a shot. Ooh, okay, so Telnet's not even recognized. All right. That may have been pulled out of Windows 8. I think Windows 7 still supported it, but that's okay. At any rate, I wasn't quite sure X server would support that anyway. So, unfortunately, I can't really demo that, but I did want to talk about Telnet and SSH so you could at least hear it. I'm sorry, so that you at least heard about it. Okay. Now, the next command I'm going to demonstrate is called ping. Let me clear the screen here. ping/?. All right. So there are a lot of options, and to be honest, I'm not going to talk about any of them. What ping it stands for is Packet Internet Groper, and you use the command to check to see if a particular computer on the network can be reached from your computer. And again, you would use this as sort of a troubleshooting technique. If for whatever reason the computer doesn't seem to be able to connect with a remote computer like a server on your network, you could use ping to try to connect to first the gateway and then the actual computer past the gateway. So ipconfig tells you what your gateway is, and my default gateway is 192.168.1.1. So I could type ping 192.168.1.1, and it will give me several tries, and if it works, you'll get this reply from how many bytes were sent and how many bytes were received from that particular IP address. So if you can connect with that gateway, then you know, okay, the network works to that point. So let's try getting to the next part of the network. So this is a troubleshooting technique. Now you can use this if you're having troubles connecting, say, to your email server, Delta's web server, some other web server, an email server, to see if there's a problem connecting to them or there's something else going on with the software that's running on your computer. So we can do something like ping www.delta.edu. You don't have to use IP addresses. Obviously, with a gateway, it doesn't have a name associated with it. So, but a web server does have a name associated with it, so you can just type in that name. And when you do start the ping, it comes back with what the actual IP address is of the computer you're trying to connect with. And you'll notice that it says the request is timing out. That's interesting. Now, part of the problem with using ping, though, is it's part of a group of commands, network commands you can use that can be blocked by server administrators. And the reason they would block it is if hackers aren't quite sure if a computer is on the internet, they can try using ping to see if they can find computers they don't know about. And you can simply, as an administrator, block your server from replying to that particular command. And ping's one of the commands that can be blocked. So the fact that the request timed out doesn't really mean anything, since I know www.delta.edu is up and running. So we can try a different site. Let's see. This is a site I go to frequently. Okay, and they don't block this. So this is what it looks like when you're trying to connect, or not connect. It doesn't actually connect. What it does is it sends a message to the server and then waits to see if the server replies to a particular specific ping message. And in this case, Delta did not reply to it, but Macintosh.com did reply to it. Okay. Now, another command you can use for checking connections is called traceroute, and this is on slide 17. It's TRACERT. And again, if you've used Linux, you recognize this as a shortened form of the traceroute command on Linux, and it does the same thing on Windows as it does on Linux, except it's TRACERT on Windows. So if you're taking both the Windows command prompt class and you're taking Linux, I know it's probably been fun with you trying to keep the two different sets of commands separate in your minds. Alright, so let's traceroute, and what you're going to do is you're simply going to specify some place you want to get to. So I'm going to specify Macintosh again. And what this does is it shows you all the devices your signal has to go through between you and the remote computer. And so the first thing that shows up is my gateway, which makes sense. That's the first device it has to connect through to actually get out on the internet. And then it has to go through all of these other devices, even though they're all at charter.com, my service provider. There's multiple devices at Charter it has to go through. And it's going through some device in Chicago. By the way, Chicago happens to be a huge oh crap, I can't think of the correct term. uh, connection point, I guess, for communications on the internet from Michigan, and also in that area for Illinois, Indiana, and Ohio. A lot of connections go through um, Chicago. Then you notice after Chicago, it went to Pittsburgh, went to, I'm not sure what 434.30.22 is, why there isn't a name there, but it went through another device, finally reached Macintosh.com at its IP address. So if you look at this, it went through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 devices between me and Macintosh.com. So one of the reasons I want to show this command is to show you that if you're having some kind of connection problem with something on the internet, it might not, in my case, might not be Charter. It may be somewhere else out there where after it leaves Charter, it goes through Chicago. So if there's a problem, Charter may have absolutely no way to correct it. If they're having problems, they'll have to wait for somebody in Chicago or even Pittsburgh to fix a problem if it's causing problems for a lot of people. Now, to get more information about traceroute, there are some options here. You can see that you can specify a -D, do not resolve address to host names. What that means is if I specify -D, you won't see these names like Saginaw, Michigan, Charter.com. You'll just see the IP addresses. Sometimes that makes traceroute run a little quicker because even after it connects through that device, it has to look up the English name, the human readable name for that IP address, and in order to display it. So sometimes traceroute runs a little quicker if you specify the -D option. All right. And then there's a few others. You can see that you can force it to use IP version 4 or IP version 6 address, and some things that are only IP version 6. I will admit that my knowledge of IP version 6 protocol and options for different things is pretty sketchy right now, so I'm not quite sure what trace round trip path is doing for sure, or what the source address to use is for, what that's used for sure. So I really can't comment on that. You can change the timeout if you notice that there's some timeout at this point. So if you know what you're doing, you can shorten the timeout if you want, or even make it wait a little bit longer if you want. But at any rate, you notice that you don't even have to specify anything to get traceroute to work for you. So, all right. With that, I am going to stop this particular video. This will be part 1. As we're getting on to about 50 minutes now, so I want to try. I was actually trying to get this entire video, or I'm sorry, all this information in one video. It's obviously not going to work, so I'm going to break now. So we'll have at least 2 videos for this particular class. So I'll see you when I start up part 2.